and start talking a little bit about Mythic 3.0, kind of what it can do some demos, see some features on it. So if you're not familiar, like what on earth is Mythic in the first place? So Mythic is an offensive C2 platform, red teaming, pen testing, that sort of stuff. It is a microservice-based platform, so it's using Docker and Docker Compose. Everything is split out into its own individual component. You do have a web UI written in React, and we use it a whole bunch at work. And so as part of doing that, we have multiple operators that are operating at the same time. Sometimes we have senior operators, junior operators. Sometimes we even have other companies sitting as part of a ride-along. So built into Mythic is an RBAC control. So you can say certain users can't do certain things. You are just a spectator, all that sort of stuff. Everybody with their own logins, all sorts of stuff. And then as part of this, there is a whole scripting engine, and you can essentially do anything you can do in the UI with scripting. It's all GraphQL, it's all open source, all available for you. So if we look at the overall architecture, it looks really intimidating at first because it is microservices, but we have just you as an operator connect up with your browser. You go through a reverse Nginx proxy, and that connects you up to a lot of the various aspects of Mythic. We have our main web server here that's processing agent requests and doing stuff like that. We have an inline Jupyter notebook container that helps you do a lot of scripting components if you want to do that. There's internal documentation for all of the agents. This is just the web UI that you hit. And Hasura is the engine we're using to provide GraphQL to hit up and connect to the Postgres database. So all of this is saved. If you reboot the server, turn everything off, turn it back on, everything just comes back up. Nothing gets lost. All that comes back into your UI. Because we are doing everything split out into individual Docker containers, as we can see here, every payload type, so Atfel, Poseidon, Apollo, all that sort of stuff, live in their own Docker containers. Makes it really easy to have their own environment, build processes, tool chains, all that. C2 profiles are also in their own containers that run their own internal servers to like bind to ports, talk to Slack, like all that sort of stuff. Same with the ability to do webhook and logging. All of that is completely customizable. You can submit to anything that you're interested in. There was recently a request, we put this back out, years ago now, because people are interested in things like Red Elk and being able to ingest that logging. Red Elk hasn't done a lot of movement on clearly defining their structures and all that sort of stuff, but because Mythic has logging broken out into its own container, you can ingest all of the logging events, change the format, do whatever you need to do, add enrichment, and then ship that off to your own SIM and include it in whatever it is that you're interested in. You're not subject just to whatever I happen to output, which is really handy. So why might you want to use Mythic over certain other frameworks that are out there? So a lot of people want to do their own agent development or customization, but not a lot of people that like to do agent development like to do UI development. And so it's really handy to be able to just focus on the agent piece, add in the special features that you want, sleep mask encryption, like what have you, and then have a unified front end that other people can connect up to. So it's really handy from that aspect. It can be sometimes difficult to swap between entirely different C2 frameworks during an engagement. It's nice to have the variations between like long haul, short haul, certain kinds of stuff, but being able to customize all the C2 aspects and your agents, you can kind of get all that while still having the same familiar interface, so that it's easier to work with each thing in the same way. Again, everything is plug and play, so dynamically as the server is running, you can just add in a new C2 profile and use it. You can just add in a new agent, remove agents, like what have you, and just kind of keep going along. This is a really big one for us, the structured input and output. So as the agent dev, you have full control over what the output of agent data looks like. A lot of C2 frameworks are expecting users to look at the data, and so you just have like text blobs that come back. However, if you're trying to do anything after that, like post-processing, looking at the data comes back, doing enrichment, analyzing it from a computer perspective, that's really annoying. So if we're able to go through and have structured data come back, and then in the UI, turn that into things like tables and graphs and buttons and all that, so it's easier for you as an operator, but still having all that data available for scripting and processing makes it really easy to do that sort of work. If you checked out the Nemesis presentation in Arsenal yesterday, this feeds into that. They'll also come in later today, I think at 2 o'clock, talking about Nemesis, which is a operational enrichment pipeline and doing a lot of analytics. So that feeds into that. Part of this is there's built-in opportunities to do OPSEC checks. So as you're going through and you're issuing tasking, before the agent can actually pick it up, you can script and run arbitrary checks. So an example is if you're going to run like a shell command, and you know that for your agent, that shell command will spin off like a subprocess cmd.exe. Before you even let the agent pick that up, you can query Mythic's backend and say, hey, do we know what kind of antivirus is running on this box? Do we have a process listing already? If not, block it. Tell the operator, hey, this has potentially OPSEC issues. You should do these other things first. And you can also go one step further and say, you can't just bypass this request. The lead of the operation has to approve this OPSEC situation, stuff like that. So it's really handy. And of course, we do have a lot of community support. So there is a GitHub website that updates every day and goes through all the various C2 profiles and agents that people have created and pulls their latest data. So you can see when they've last updated, you can see what they're doing, what agent it is, what their commit message are. You can even go right to the GitHub repo. This is an interesting one over here. You can actually see over time how many people are viewing and cloning the project to get an idea of like, is this actively maintained? Are people really using this? Or has this kind of fallen off over time type of deal? So you get a lot of insight into the community being able to use this as well. So this talk is a lot about Mythic 3.0. So just released this back in March with a huge overhaul. So Mythic is almost 5 years old now. A lot of things have changed over time. I've learned a lot about agent development. So I went through and the old UI was, and the backend was in Python 3, completely redid the entire thing, rewrote it in Golang, a lot more performant. For example, like issuing tasks used to take maybe 1 second, and now it takes about 18 microseconds. So things are so much faster in processing and handling everything. Webhooks and logging split out into their own containers. This was another thing. A lot of people like to have webhooks for new callbacks and stuff like that. But you know, if I have everything bid out for Slack and you like to use Mattermost or Discord or something else, it wasn't easy to do that. Now you have full control. You can do all that. There's also now like reverse port forwards, and you can group your callbacks based off of certain attributes. And I'll show this so you can see like all your callbacks grouped based off of host or based off of IP address and stuff like that. Built-in Jupyter Notebook scripting, tagging, all sorts of stuff. So a lot of talk. Let's actually look at Mythic itself. So if you log in, we'll come over here. So this is kind of like the home page of Mythic. It gives you an overview of what agents you have installed here, Atfel, Apollo, and Poseidon, and the C2 profiles that they have, and which ones support which C2 profiles. So you can see here, like Apollo supports HTTP and SMB, but you can't communicate over WebSockets with it, for example. So pretty easy overview going on there. If you come up here, you can see all the various agents and C2 profiles that are installed. You can view information on all of them. You can view, like, clicking this will show you what build parameters they take. So Apollo, in this case, can build out to Windows executables or give you shellcode, all sorts of stuff like that. So if you come up here, you can see the various payloads that have been built. And so this gives you a lot of information about what you're building and historical data. The interesting thing here that was just added in 3.0 is this build progress. So not every agent takes the same amount of time to build, right? Building a obfuscated Golang agent could take a long time versus just like a PowerShell agent. They're just like stamping files together. So as part of that, you can create these build progress that dynamically updates during build time. And so you can see like this step succeeded. It found all the files it was looking for to even be able to do a compilation in the first place. Here we can see it's compiling. That took 16 seconds. And then finally here, I didn't put it through shellcode, so it's just passing through. And we can see that all in real time here. A lot of options that you can do with your payloads. So I'll just go ahead and trigger a new build of this agent. So if we do that, we see it pops up here, and you can see how it's going through. It's compiling right now. It already went through and found all of its files. It showed it took like 16 seconds before, so it'll take about the same amount of time now. And then we'll go ahead and get that through there. Well, actually, I don't have internet. This container goes through, when it does Apollo, it does NuGet packages. So this might not actually build if it can't actually reach out to the internet. Yeah. So it failed, and it's sending out all this information. So it's telling you it's using NuGet, all of this. And down here at the bottom of the build process, it's probably going to say it failed because it couldn't actually fetch the NuGet packages. Yeah, no such host is unknown. I don't have internet, so it can't build. But you get that sort of real-time build feedback. Before, you just had like a spinny circle and you waited for a while and then you got an error or not. So it's a lot better this way. So say you build some agents, you kick them off. Up here is the active callbacks. If you've used Cobalt Strike, this view is kind of familiar. You have like your table and information. So you can see here, same sort of idea with Cobalt Strike. Red indicates high integrity, blue is normal integrity. You have your IP host information, when it last checked in. So we can go ahead and sort by that, when things are connecting up. And so as part of this, this is a new build that I'm doing. I haven't quite released all of this yet. And so we have this last check-in here of streaming now. So as part of Mythic, with having all of your C2 profiles split out into their own Docker containers, you can really do a lot of various things. Historically, especially looking at like red teaming frameworks, it's an async like callback check-in. But if you want to do something like socks, that means you have to sleep 0 and you have a whole lot of freaking traffic coming in and it's not all that great OPSEC-wise. So a new thing I'm adding in is this ability to do push-style C2. So normally you may think of, for like a peer-to-peer agent, it binds to a port and listens. Somebody connects up to it and just kind of waits for things to get sent to it. This push-style C2 makes that same sort of thing available for your egress agent. So your egress agent makes like a WebSocket connection out, holds it open, and just kind of waits. Mythic sees that connection and then can send it tasks, not having to do that really brute processing going on there. We can hear other ones just kind of checking in as they go along. One of the interesting things is, say we have like a linked agent. It's helpful to try and figure out like what are the connections for that agent, like how is it actually talking out. So for any of these, you can actually click them, and Mythic will build up just the egress path for that callback and its parent children. So you can see here, the callback 5 is using Poseidon TCP to talk to root, callback 4 talking to callback 3. Go ahead and zoom out, and that's communicating over WebSockets to Mythic. So you can see just that small isolated form there. You can also go through and adjust how things are grouped. So to make this a bit easier to see, we're going to go ahead and come up here and look at the graph view for all of our current callbacks. So we have a couple here that are using Poseidon and Atfel on spooky.local, and we have a couple of these Apollo agents on this Windows desktop. Immediately, you can see grouped based off of host what callbacks are running where. But maybe host isn't the easiest way for you to view. So we can show the group options and say, I want to have things grouped based off of user. So here we have the root user, the it's a feature user, and this is a high integrity it's a feature user. So you can see how things are connected and routed that way. Maybe it's easier to see things grouped based off of IP address, like all sorts of things that make it a bit easier looking at operating system versions, just to have your sort of aggregated data. Now, you can also change what data you display. Like maybe I don't care about the ID, I want to see the host and the IP for each of these callbacks. So you have all this, and then you can go ahead and actually save this view out as a PNG or SVG. So you can have that include in a report, for example, for that sort of data. So pretty easy to go through and see all the stuff that's happening there. As part of this, so we have, if we go back to our table view, each one of these you can interact with and start issuing tasking. So here I listed on macOS, if you're not familiar, there's the entitlement system with all the processes. So I ran a list entitlements command, and here I see some text data about things I'm interested in and a table. So this is something that I, as the Mythic developer, had no control over. This is what the agent developer decided to do with their structured output. And so they made buttons. These don't have anything. These, you can see, will show like pop-ups. This disables library validation. You can add in additional actions if you want to view, list a path, download, what have you. All of this available. And if you want to see what the actual data is, you can turn off the browser script, and all they sent back was this structured data. So you can easily feed this into other pipelines, or for your user, you can just make tables. And of course, with all of this, we can filter. So let's say maybe I want to scroll down here. I want to do a search on this data for, I don't know, disable. So now our table got filtered to only include rows that have the word disabled in them. So it makes it even easier for you to do this sort of processing inline. And you have full control over how all of this works, which is pretty handy. Yeah. And the nice thing is like all this has documentation. I don't control any of this. You can make all your own buttons and icons and what have you. So pretty handy. Same with like output. I think, let's see, callback. I think it's up here. I did it this one. So even like this one going through to do a PS on a Windows agent lists out, your session, your information, and you can even highlight rows and say like, this one is interesting. The downside here is that, why is this row blue? I mean, you don't know. You'd have to like go in and read documentation, or why is this row red? So to help out with this sort of stuff and add more value to the data that you're getting back, Mythic has this idea of tags. So we can go ahead and I'll look at a process browser. So if we scroll through and look at a process browser, we can see these various tags here happening on the side. So now instead of just being like yellow or blue or some arbitrary thing, now you have additional context and you can click these and see like, this is an agent callback that I just tagged as part of your process listing, where it came from. I did this with Mythic scripting. And if you have additional reference URLs, like maybe CVE links or data that you want to provide, you can do that here, as long as additional with any data you might want to provide. And so you can at any time click these little tag icons and see what's up with them. You can add new ones, add in data, all that's available for you. And we can even come up here in the tags and see all the ones that exist, in addition with how many times that they're used. So this gives you kind of feedback. You can, of course, change all the colors and all that sort of stuff. But this also is really handy if you want to search your operation. So Mythic is tracking everything in the database. And so there's no reason for you, if you close your UI, to lose all of that. We can fetch and search for it. So you can search for various hosts that you have. You can search across all of your tasking for like various output. Like at some point I did a task that referenced a password. I don't remember what it was. So you can just search the output for that word and it'll get all those tasks. So like here, let me look at output, and I want, it's a feature. These tasks had output that listed it's a feature. So it's really easy to do that. You can even filter, like I only want ones that actually completed successfully or had certain errors, all that sort of stuff. You can look at files that you've uploaded and downloaded. Gives you easy information. As part of this, you can see all of the hashes associated with those files. And as a handy kind of quick reference, for any file that you upload or download, you can preview the first 512 kilobytes. So the first 512 kilobytes as strings displays it out for you there. This is just a simple little script. You can also, if it's like binary or PDFs or stuff like that, you can view it in hex XXD format. So it makes it a bit easier to kind of sift through, see what's going on. If you modify this stuff, you're free to tweak it as you want. It doesn't save it on the back end, but if you need to like do a little bit of processing to make the output easier for you to view, you can do all that there too. Really handy. And you can do that for uploads, downloads. You can look at the file browser and see the stuff that's coming in there. Screenshots if you had any. You can look at all the credentials that you found. This is like your credential store. You can see where it came from. You can see like I got these from task 15. All that sort of stuff, pretty easy. One of the interesting things is that, let me get rid of this part, is that agents report back artifacts about what's going on. I don't know about you guys, but when we do operations, we need to keep track of what processes we're spinning up, what we're doing for deconfliction. With some stuff like Cobalt Strike, it'll do that fork and execute, but it's hard to know like what was the PID of the thing it just sacrificed for you to run your command. You don't get that data back. Here, agents can report that. So here we have Apollo doing an execute assembly, and it reported back, it started run DLL32, this PID, it injected into that PID using create remote thread, and then it killed it. So now as you go back, you can work with defenders and say like, here, this is the timestamp this happened, I injected into this one to run this sort of command. Makes things a lot easier to kind of see what's going on. Yeah. Yeah, exactly. Yep. You can, of course, go through and look at all of your processes as well and see like all the tagging and stuff that we were viewing before, in addition to looking for just specifically things that have been tagged. And you can see like this is from the process browser. These are all from the process browser. But you can just go ahead and see all that sort of data available for you. Of course, you have, well, here, this is an interesting one. So say we have this big process list. I want to go through and search for my agent, Apollo. Sweet. I found the information for Apollo. But if you notice, as part of this search, I just lost the context. Like, what is it Apollo's parent? So it's not easy to see there. So what we can do is we can actually say, I want to view just this process's tree. And so it'll show you the child processes and information associated with it. So it's pretty handy to see all that stuff there. There we go. I was sorting on it, so let's unsort. And so you can see the tree that comes down to Apollo. And anytime you're done with this, you're just like, all right, I'm done. I can see the rest of the data that's going on. You can do the same sort of stuff with the file browser. You can see all the various hosts. And let's see, you can come down here, highlight what folders have data, they're yellow, what ones we haven't listed, they're kind of grayed out. And this little check mark here means that we explicitly listed the contents of this folder. By listing this, I learned that this path exists, but it's helpful to know like where that data came from. So you can go ahead and like list additional tasking from this. You can view data here. You can view permissions and download history and issue additional tasking and all sort of stuff straight from here. So it's really, really handy to kind of have all that data available for you. And of course, what we just did before with the filtering of the table and searching for names and stuff, we can of course do the same thing here. I want to filter for like a username of root, and it's just this one here. So pretty easy to go through and make all that stuff easy to see available for you there. So as part of this, I mentioned that there are like RBAC, so you can have various operators. So if you click up here for your operation, you get a lot of details about your operation and block lists. So here we have, this is the Black Hat 2023. If we click for the operators, we can see I'm part of this and also Bob. I am the lead. Bob is just an operator. He could also be a spectator if I wanted. And he has a block list of this block execute. So if we come down here, this block execute list says for the Poseidon agent specifically, you can't run execute Mako, memory, get env, or set env. So I am currently logged in here as Mythic admin. So let me go to here where I am logged in as Bob. Yeah, so Bob will be prevented from running any of those. So like if we come here and get env was one that was blocked, so I'll do, oh, of course, all this is tab completable too. So I just typed get and I can tab. So he can't do get env, so I hit enter and you see, bam, he was prevented from doing it in the first place. One that's a little bit different is if I come up here, there is a command, Chrome tabs. On macOS, you can like communicate with other applications. The first time of a certain tuple, it'll cause a pop-up. So what I do is I say here, you issue it offset blocked. So before we can even try and execute this, I went ahead and blocked it. You can come down here and see a little lock icon, and it says, this pop-up, this task will cause a pop-up. Are you sure you want to do this? So even if I, as the lead, said I'm okay with this, the schedule for this says another operator must do this. So let me come back over here to Mythic admin. He needed other support to do it. I think it was even if it is open, you will get the pop-up. What callback was that on? It was on 6. 6. So the issuer couldn't bypass it. You can set, another user or lead. So in this case, I said another user. So I come over here. I say, all right, submit this request. It's okay if it causes a pop-up. Now it goes through, agent processes, pulled the data. Now, because we already have data that this task has been run on this host, the next time we try and do it, if I try and run Chrome tabs again, it automatically goes into submitted. The agent is able to pick it up because what I was worried about causing a pop-up is no longer a case. We've already run it. So you can do those sort of dynamic checks as you want for any sort of OPSEC, and you can query everything as part of Mythic and view that sort of data. Uh, yeah, so that was a lot of stuff. Um, more. Um, yep. Okay, so the question was macOS specifically. If you want to do a screenshot, you actually get a pop-up based off that request to do that. It's a TCC protected event. The downside is TCC is protecting that as part of the system TCC database, and that is a SIP protected database. So even if you have full disk access and are root and all that, you will still cause a pop-up, which is a bit unfortunate. But yeah, so another interesting thing, I guess, here for the graph layout is that, so this is showing the flow of data. So when this callback sends data, it goes directly to Mythic. This one hops through these three. By looking at data this way, we are missing a little bit of information about necessarily the direction of connections. So you can come over here and say, I want to view connection directions. So this changed it a little bit differently in that we have these agents reaching out to Mythic. This agent is reaching back out to callback 4. So callback 4 just bound to a port, and we reached into it. The reason capturing that sort of data is important is if you're looking at firewall rules and network segmentation, the order of connection matters a lot. So this is a different view if you're worried about checking those sorts of things. More often than not, you only care about the egress route, like how does my data get back to me? So a little bit different there, but you can, of course, view left to right if that's easier for you to do that sort of stuff too. Another interesting thing is, let's see if I have an example here. So any task you issue is also able to issue subtasks, issue further on tasking. So in this case, for the Apollo agent, I issued Mimikat to curl cell logon passwords. What actually happened with Apollo is it went through and built a specific DLL that it then used to inject into a process and execute things that way. So we have those as two separate tasks that get issued. This one specifically as a child process of this one. And you can do all sorts of scripting and hooking as part of that to say, when this task issues this subtask, execute a function in here that I create so I can inspect what that task did, and if it succeeded, failed, had certain output, I can then issue even more follow-on tasking. So you can get very complex in how you want to script this stuff out. And of course, you can see logon passwords and stuff like that. This specific command here, the Mimikatz one, has its own completion function that then, because it knows Mimikatz, it checks the output, searches for things like the plain text password here, and will automatically generate the your password entries up here. So these were automatically generated just by scraping it because that command completed. And you have full control over all of that, which is really handy. A couple other things to note, I mentioned that there is like the scripting capability. So over here into services, if you click Jupyter Notebooks, so this opens up internally, proxied by the reverse Nginx proxy, an internal Jupyter notebook that has all sorts of stuff. And so down here is a whole bunch of examples for things. If you want to go ahead and like pull files, process them, issue new tasking, change operator configs, like all sorts of stuff available for you here. Up one layer, this full script examples. This is actually the example that I used to go through and start tagging like processes and stuff like that with my agents and all of that. This is pulled from up here, this process tree CNA. So I just converted it into a little Python script, pulled out the definitions. These are the tags I want to create in their color. They had all these for AV-related tasks, even more. All these were like marked as admin. And so then all I do is create a couple of functions that say like, I want to get certain tags, add tags to like this process entry. And then down here, log into Mythic, get tags and callbacks. This is all GraphQL, so you can issue custom GraphQL. So I say, I want to get all my processes, and I specifically want things like the name of the process, the tag, like all that. And then I just loop through. And for each process, I issue a tag, check if I need it, like all this. And you can have this running all the time. And so that's what happens down here. It logs in, finds your callbacks, finds processes, tags them, and that's what we end up with over here in the UI when we look at the process listing here, and we have like these things getting tagged. So pretty easy and straightforward. Of course, you can like sort all this and sort by PID and all that sort of stuff. That's pretty handy. Is there anything specific? Yeah. Can you what? Can you run them? So the question is, if you have an agent and you want to run like a custom executable, how do you do that? So let's go to Apollo. So Apollo has a register assembly command. So the downside to having this in the browser is that you don't have full like access to your host. If you did have immediate access to your host file system, there would be a whole slew of other issues with your browser. But what we can do is we can register files. So an example here, if I do register assembly, and I hit enter, this takes a file. So you just get a pop-up, you select the file that you want to upload. And then down here, whenever you want to run it, you can just pass in like tab complete arguments. I want to run and the name that I uploaded, seatbelt.exe, seatbelt, and the arguments that you want to do. You can get very complex or very simplistic with arguments that you provide. Any argument that you provide, you can tab complete. So if I do execute assembly space, and I just start hitting tab, I can see the two arguments that it's expecting. So I could do test, whatever, space, and now I hit tab again. There's only one argument left. So naturally, that's the only one I can tab complete. So you can issue things that way. At any time, you can also shift enter, and you'll get a UI version for you to go ahead and do this. And so this one specifically, this dropdown is auto-populated by the agent's code on the back end. It queries Mythic and says, hey, for this callback, have you uploaded any files? If so, give them back to me and give me the name, seatbelt.exe, so you don't have to remember the name of what it is or any of that sort of stuff. Mythic knows it, so it can fetch it for you, and then you can just provide any arguments that you're looking for. Yep. So the question is, can I add the auto-completion for seatbelt? So in order to do that, you would just create a new command in Mythic for seatbelt, and you just define all the arguments. And then, yep, you can tab complete. And let's see, for here, I will do. So another interesting thing about the commands, especially for things like seatbelt that gets really complex, is you can create named parameter groups. So what we're doing here, this is the SSH auth command. You can auth with like a plain text password with an SSH key. You could SCP, like all this sort of stuff is built in, but it doesn't make sense to include like a plain text password and a path to a private key. So you can group these and say these 5 parameters make sense together. These other 2 make sense together, and you can't use certain ones together. So you can just switch this and see here, now I want to run with private key. Now I have path to a private key to supply. If I say run with plain text password, now I supply plain text password. And you can define all of that however you want in your own command files, and then make it a bit easier for the user to do things. This sort of stuff also plays into the tab complete. So if you have 2 parameters that aren't able to work together, and you supply one, tab complete won't provide the other one anymore. So it knows about all that sort of stuff. And of course, you can provide like arrays of data. You can provide strings, files. You can even go through for, let's say here, if I want to link up to another host, if you know the address and port, fine, you can connect up directly to it. Sometimes if you're doing things with like name pipes, you might not know the name pipe that's being used, or you might want it to be randomly generated. So Mythic allows you to look in the database to see what payloads are created and automatically populate that data. So I can say, I'm looking for things that are running on this host. Here are the payloads that exist, so I can connect up to this callback that's running, or these payloads that I know are dropped in. And when you select them, it automatically knows, hey, here's like the port, here's your encryption keys, like here's all your data. Just issue that to your task and go along. You don't have to manually remember all of that data. So it's pretty easy since Mythic's tracking all of it already.